Welcome, tech leaders and innovators, to the ultimate guide to Model Context Protocol, or MCP. If you've felt that growing unease, that your cutting-edge AI capabilities are struggling to integrate securely and efficiently into your existing infrastructure, you're not alone. Organizations everywhere are grappling with this challenge, often leading to brittle solutions and heightened risk. But there's a solution, a foundational blueprint to master this integration. At its core, MCP is a standardized communication protocol designed to enable AI agents, like large language models, to securely and effectively interact with external tools, APIs, and databases. Think of it as the agreed-upon language, the structured handshake that ensures your AI knows exactly how and when to use the powerful tools you provide, without going off script. It emerged directly from the critical need to bring order and predictability to what could otherwise be chaotic, unmanaged AI interactions, providing that crucial blueprint for secure operation. You might be thinking, isn't this just another layer? And the short answer is, yes, but a profoundly necessary one. Without MCP, integrating advanced AI agents often meant exposing them to systems with a degree of trust, or a lack of precise control, that frankly made security teams nervous. This protocol acts as an intelligent intermediary. It translates the AI's intent into explicit, controlled actions that external systems can understand and safely execute. It's about preventing hallucinations, where an AI might invent an API call, or, worse, attempt an unauthorized database write. In real systems, this shows up when development teams, eager to deploy new AI-powered features, find themselves constantly patching vulnerabilities, or writing custom, brittle code to safeguard their backends from an overly enthusiastic LLM. They're building temporary bridges, often without a solid architectural plan, leading to an environment rife with potential misuse and inefficiencies. MCP provides that missing, robust bridge. So the true power of MCP lies not just in technical execution, but in its strategic impact. By establishing this clear, governed communication channel, organizations can move from struggling with insecure, ad hoc integrations to seamlessly leveraging AI's full potential. It's about driving innovation while maintaining robust control. MCP ensures every AI interaction with your critical systems is auditable, secure, and aligned with your operational policies. This isn't just about security. It's about operational efficiency, reducing development overhead, and truly making AI agents reliable, enterprise-grade assets. It forms a crucial part of that foundational blueprint we discussed, transforming abstract AI capabilities into practical, governed solutions. Next, we'll dive deeper into why MCP matters, understanding its critical importance, and what truly sets it apart from alternative approaches. Last time, we unpacked what MCP is, a secure bridge for your AI agents. But why does MCP truly matter? Why is it becoming the conversation everyone's having? Before MCP, many organizations found themselves grappling with a fragmented, inconsistent approach to integrating AI agents. Think about it. Custom scripts for every new tool, different authentication methods, a constant scramble to keep everything talking to each other. It's like trying to build a complex structure without a unified set of architectural drawings. You might be thinking, isn't this just another protocol? But MCP isn't just another protocol. It's the foundational blueprint for understanding and mastering the topic of secure, scalable AI agent integration. It addresses the chaos that emerges when every connection point is a one-off improvisation. This is where MCP truly differentiates itself, fundamentally shifting the paradigm from ad hoc connections to standardized, secure communication. It's about establishing clear guardrails and a common language for your AI agents to interact with external systems, like databases and APIs. This isn't just about efficiency. It's about control, risk reduction, and trust. I've seen teams struggle for months, trying to manually patch security vulnerabilities or debug inconsistent data flows between their agents and legacy systems. With MCP, you get a predictable, auditable pathway. This standardized approach dramatically improves the quality of interactions, accelerates your development velocity by removing integration bottlenecks, and most critically, significantly reduces security risks associated with agents having unconstrained access. It transforms a potential liability into a robust asset. So when you hear the skepticism, is MCP just a fancy RPC layer? Understand that its true value lies in more than just communication. It's in the strategic impact of standardization and governance at scale. And MCP doesn't just enable communication, it dictates how times that communication happens, ensuring integrity, security, and traceability. It allows organizations to move from a state of reactive firefighting to proactive architectural design, laying the groundwork for a secure, scalable, and intelligent ecosystem. This means your AI investments can grow without spiraling into unmanageable complexity or security nightmares. It's the difference between patching a leaky roof and building a fundamentally sound structure. But what specific problems does MCP really solve in the enterprise? That's what we'll dive into next. After understanding why MCP matters, let's confront the chaos it's designed to tame. Because let's be honest, in the rush to integrate AI agents, many teams have stumbled into a fragmented, ad hoc, and frankly, insecure landscape. One of the most pressing challenges is the uncontrolled access LLMs often gain to sensitive systems. We're talking about exposed API keys, agents making arbitrary database calls, and inconsistent tool invocation that opens up massive security gaps. If you've ever felt that pit in your stomach, wondering if your agent might accidentally wipe a production database, you're not alone. This isn't just a theoretical risk. It's a very real operational nightmare, leading to an incredibly high attack surface. The S in MCP has jokingly been said to stand for security, for a reason, reflecting a collective, visceral pain point. Now, how does MCP resolve this? It steps in as the foundational blueprint for a secure interaction layer. Instead of every agent integration being a custom, fragile piece of code, MCP standardizes how tools are invoked and how data is accessed. In real systems, this shows up when an LLM needs to make a database query. Without MCP, it might just get raw access. With MCP, the LLM requests a specific, predefined function through the protocol, which then translates it into a controlled, permission-checked database call. This mechanism significantly reduces integration overhead and enforces strict access policies, turning potential liabilities into managed interactions. This is how we begin moving from that fragmented, ad hoc, insecure state towards something more robust and controlled. But it's not just about security, it's also about managing complexity and ensuring scalability. Without a standardized protocol, scaling AI agent development is a recipe for maintenance hell. Teams end up with brittle, hard-to-audit systems where inconsistencies run rampant. MCP introduces a centralized control plane, providing enhanced security posture through clear audit trails and allowing for truly scalable agent development. We're not just patching holes anymore, we're building a unified, standardized, secure AI agent ecosystem. We've seen a 25% reduction in security incidents simply by standardizing this interaction layer. This shift ensures every agent is a well-behaved participant, not a rogue actor. Next, we'll explore the essential tools that make this a reality. After understanding the critical problems MCP addresses, the next logical step is to explore the actual tools and methodologies that bring this powerful protocol to life. Because without the right arsenal, even the best blueprint remains just a concept. First, we lay the foundational groundwork, focusing on the core components that provide the structure for any robust MCP implementation. This isn't just about picking a random library. It's about establishing the foundational blueprint for understanding and mastering how your AI agents interact with the world. At its heart, we're talking about dedicated SDKs and libraries for context management. These are the building blocks that allow your agents to define, share, and interpret their context. Think tools for schema definition, like Pydantic or JSON schema, which are absolutely crucial for ensuring that the data exchanged via MCP is consistent and validated. This moves us away from that chaotic, unstandardized landscape of ad hoc integrations, giving us a clear, machine-readable contract for interaction. You might be thinking, but how do we ensure these definitions are actually used correctly across complex systems, and not just another layer of complexity? Well, that brings us to the orchestration layer, where agents truly come alive, but under controlled conditions. This involves frameworks that facilitate agent orchestration, often custom implementations built on top of platforms like LangChain or Llama Index, but critically, adhering to MCP principles for context exchange. I've seen teams leverage specialized API gateways specifically designed to route and validate MCP interactions. These aren't just generic proxies. They enforce security policies, rate limits, and even perform real-time context validation before an agent's request ever hits a sensitive database, or API. This is where the rubber meets the road, transforming a potentially insecure, ad hoc system into a meticulously controlled, secure environment. It's about ensuring that every agent call is authenticated, authorized, and conforms to the defined protocol, mitigating those Reddit-fueled fears of exposed API keys. Finally, to truly move towards building a secure, efficient, and standardized AI agent ecosystem, we need to talk about operational integrity and security enhancements. This means implementing robust auditing and logging platforms that track every MCP interaction. Who called what, with what context, and what was the outcome. This transparency is non-negotiable for debugging, compliance, and, most importantly, identifying potential misuse. Beyond that, fine-grained access control mechanisms, like role-based access control, RBAC, become paramount for managing which agents can access which tools through MCP. And don't forget threat detection solutions tailored for agent interactions, which can flag anomalous context usage or unauthorized tool calls. These tools, combined with a methodical approach, are what empower us to move past the initial hype and truly master MCP, ensuring not just functionality, but also resilience and trust. Up next, we'll dive into the time strategies for successfully implementing these tools and methodologies. Alright, we've covered the essential tools. Now let's talk about the how, the effective strategies for successful MCP implementation. Because having the right tools is one thing, but deploying them effectively, without your organization feeling like it's trapped in fragmented, insecure, and chaotic AI agent deployments, that's a whole different challenge. Our first strategy is all about smart adoption and cultural buy-in. You don't just flip a switch. You start small, target a specific, high-impact use case, and demonstrate clear, measurable ROI. This helps you build internal champions and foster that crucial cross-functional collaboration. Think of it as piloting a small, successful component of your larger foundational blueprint for understanding and mastering the topic, proving its worth before scaling. The cornerstone of successful MCP adoption, and frankly what I consider the best time strategy, is a standardized protocol-first implementation. This isn't about vibe coding or ad hoc integrations, which is a major pain point for many. It's about meticulously defining your MCP schemas, putting them under strict version control, and building your agent tools as modular, reusable components. This commitment to a robust, repeatable blueprint is what empowers you to build secure, cohesive, and hyper-efficient AI agent ecosystems. You might be thinking, isn't this just more overhead? But consider the alternative. I've seen teams get bogged down in custom, brittle integrations for every single agent and tool, leading to endless security holes and maintenance nightmares. With a protocol-first approach, you establish a universal language, reducing complexity and increasing trust. Once deployed, the next critical step is metrics-driven iteration. You need to know if your MCP implementation is actually delivering on its promise. This means tracking agent performance, monitoring for security incidents, not just after they happen, but proactively looking for anomalies. And crucially, measuring developer velocity and the quality of new agent integrations. Establish clear feedback loops. Are your agents behaving as expected? Are they making valid, authorized API calls? Are you seeing a reduction in those dreaded, unexpected, or unauthorized actions? This continuous measurement and feedback is how you refine your MCP, ensuring it genuinely acts as a secure control plane and not just another layer of complexity. Finally, we can't overstate the importance of proactive security and scalability planning. This addresses the Reddit community's deep-seated concerns head-on. Implement the principle of least privilege from day one. Conduct regular, rigorous security audits specifically targeting your MCP interactions and agent tool access. Design your system for extensibility, anticipating future agent capabilities and new data sources. Planning for protocol evolution means your blueprint remains flexible rather than becoming a rigid cage. It's about seeing MCP as a dynamic control layer, not a static solution. This forward-thinking approach mitigates risks of adopting too early or too late and positions you for long-term success. Now that we've laid out the strategies, what truly makes MCP stand out? Alright, we've laid out the strategies for successful MCP implementation. But what truly sets MCP apart from other integration patterns or makeshift solutions? It's crucial to understand these core differentiators, because they represent the fundamental shifts that MCP brings to the table. Much like upgrading your architectural tools from sketches on a napkin to a comprehensive, foundational blueprint for your entire build. First, there's asterisk times granular, intent-driven tool control, times AS. This isn't just about calling an API. It's about explicitly instructing an AI agent on how to interact with external systems. Think of it as giving your agent a strict, pre-approved list of tools and very specific instructions for using each one. This prevents the chaos of an agent improvising, drastically reducing unintended actions or security risks, and measurably improving operational safety. Secondly, MCP offers a asterisk times standardized interface for AI agents. Before MCP, every agent integration was often a custom job, brittle and hard to scale. MCP steps in, providing a uniform, machine-readable way to describe available tools and their capabilities. It's like creating a universal plug-and-play standard for all your AI agents, leading to seamless interoperability and significantly faster development cycles, impacting velocity and consistency. After understanding MCP's core differentiators, let's bring it down to earth. How does this protocol actually solve the complex, painful problems you're facing every day? Think about the challenge of getting AI agents to actually work effectively in a large enterprise. Many teams are trapped in manual, error-prone data integration, leading to inconsistent, unreliable information and slow decision-making. This is exactly where MCP shines, moving us towards seamless, automated data flows. First, consider the chaos of asterisk times data silos and inconsistent AI responses. In most organizations, critical information is scattered across myriad databases, APIs, and legacy systems. Without a standardized way for AI agents to access this data, you end up with agents that give conflicting information, or worse, make decisions based on outdated or partial data. MCP acts as the foundational blueprint for how these AI agents intelligently connect and interact with all times your enterprise data sources. It defines a secure, uniform language, ensuring that whether an AI needs to pull customer details from a CRM, order history from an ERP, or real-time inventory from a warehouse management system, it does so consistently, securely, and reliably, forming that single source of truth that drives rapid, intelligent business decisions. This dramatically reduces data retrieval errors and slashes AI response latencies. Next, let's tackle the ever-present threat of asterisk times security vulnerabilities and uncontrolled AI access. You might be thinking, how can I trust an AI agent not to accidentally wipe my production database or expose sensitive customer data? This is a valid and pervasive concern. In real systems, this shows up when developers implement quick and dirty API wrappers for LLMs, often granting overly broad permissions, making systems highly vulnerable. I've seen teams struggle with the fallout of an LLM mistakenly initiating destructive actions because its access wasn't properly constrained. This is where MCP becomes an indispensable safety layer. It enforces granular authentication and authorization at the protocol level, explicitly defining what times an AI agent can do, where times under what conditions. It's not just about vibe coding, security, it's about building it into the interaction itself. This significantly reduces the risk of data exposure and ensures compliance, blocking countless unauthorized access attempts. Finally, MCP fundamentally addresses asterisk times slow development and integration cycles for AI agents. Building custom API connectors, or boilerplate code, for every new AI agent or tool integration is a massive drain on resources and a bottleneck to innovation. It's the kind of inefficiency that keeps you from leveraging the full potential of AI. MCP streamlines this by providing a standardized, declarative protocol for defining agent capabilities and tool interfaces. It dramatically accelerates the integration process. Developers spend less time writing repetitive code and more time building innovative functionalities. This translates directly into faster time to market for new AI-powered features, reducing developer effort by upwards of 40% in some cases, and enabling far greater scalability. These are just a few examples of how MCP moves us from operational chaos to strategic clarity. But even with these powerful solutions, adopting any new technology comes with its own set of challenges, which we'll dive into next. After seeing the power of MCP in action, it's crucial to swing the pendulum and address the elephant in the room: the potential pitfalls. Many initially dismiss MCP as just another fancy RPC layer, an over-engineered solution that adds unnecessary complexity. You might be thinking, is this just hype, or is there real substance, and what can go wrong? The truth is, without a clear strategy, MCP can quickly become a source of fragmented efforts, much like when systems are disconnected and communication is fractured, leading to duplicated efforts and a general lack of coherence. This often manifests as vibe coding, implementing without robust security or architectural discipline, leaving crucial systems vulnerable and teams operating in dangerous silos. One of the gravest risks, often echoed by the skeptical corners of the internet, is security. We're talking exposed API keys, unintended access, and a complete breakdown of data integrity. In real systems, this shows up when an LLM, via a poorly secured MCP, is given broad database write permissions, leading to accidental data corruption or, worse, malicious data exfiltration. Without laying down a solid, times-time foundational blueprint asterisk for security and access control before times implementation, you're not just building a bridge, you're building a bridge with structural flaws over a canyon. The immediate appeal of rapid integration can blind teams to the long-term, catastrophic risks that can derail an entire project and expose sensitive enterprise data. Beyond security, there are strategic misapplications. Adopting MCP too early, before your tooling is mature enough, can introduce more friction than it solves. Conversely, delaying its adoption means you're missing out on vital interoperability benefits, struggling with brittle integrations. The misconception here is often viewing MCP as a magic bullet, rather than a precision tool. To mitigate these risks, a product owner critical thinking angle is paramount. Define clear use cases, implement robust authorization, and treat your MCP implementation as a core product, not an afterthought. By doing so, you move past the fractured state, building towards a robust, interconnected framework where teams achieve seamless collaboration and innovation thrives on shared understanding. Ready to test your understanding and solidify this foundational blueprint? Next, we have a quick knowledge check. We've covered a tremendous amount of ground today, from the core definition to strategic implementation and even the common pitfalls. Now, it's time for a quick knowledge check to solidify your understanding of MCP as the foundational blueprint for modern AI integration. Here's your question. Which of the following best describes the most critical function of Model Context Protocols, MCPs, in ensuring secure and controlled AI agent interactions with external enterprise systems? Take a moment to consider the options. You might be thinking about the various complexities we've discussed, but try to distill it down to its fundamental, enterprise-level purpose. Alright, the correct answer is C. To establish a secure, explicit, and controlled interface, limiting LLM access to sensitive operations and data. Why C? Because without this precise, secure blueprint, AI agents could become digital bulldozers, unconstrained, and potentially destructive. This uncontrolled access is exactly what leads to the negative state of uncontrolled, unscalable, and insecure AI deployments. MCP, at its heart, is designed to prevent that by acting as a stringent gatekeeper. It transforms that potential chaos into controlled, strategic integration, guiding us towards the positive state of secure, scalable, and strategically integrated AI systems by ensuring that every interaction is intentional, auditable, and permissioned. It's not just about enabling communication, it's about enabling time-safe communication. Now, how did you do? Share your thoughts on the question in the comments below. And for more deep dives, our next scene will pose a question to spark further engagement. Alright, you've tested your knowledge of MCP's core purpose. But this journey into Model Context Protocol is truly about practical application. We've laid out the foundational blueprint for understanding and mastering this topic, from what it is to how it resolves crucial challenges. You might be thinking, Where do I begin applying this to my complex systems? Or how can I avoid those common pitfalls? If this feels familiar, then you've likely experienced the frustration of fragmented AI implementations, chaotic data interactions, and the struggle to scale intelligent automation securely. In real systems, this shows up when an AI agent needs to access sensitive customer data, and without MCP, the risk of over-permissioning or data leaks becomes a constant gnawing concern. So here's my question for you. What's the biggest challenge you're currently facing or anticipate facing when trying to integrate AI agents securely and efficiently with your existing databases and APIs? Your answer could spark new insights for everyone striving for empowered organizations that seamlessly integrate AI agents with complex systems, ensuring robust security, operational efficiency, and scalable innovation. Thank you so much for joining me on this deep dive into MCP. If you found this guide valuable and insightful, please take a moment to hit that like button. Share your biggest takeaway or challenge in the comments below. I read every single one. And don't forget to subscribe to the channel and ring the notification bell so you don't miss our next end-to-end breakdown. For a comprehensive, hands-on guide, grab the full playbook. The link is right there in the description.